Hey everybody, David the AI Guide here. Welcome to another episode. Thanks so much for tuning in. So today we're talking quantum computers, and this is an ongoing topic that's a favorite here. Today's discussion will tell us how far quantum computers have now gone, but more importantly, how much further they do need to go to be practical and useful. So there is an article that just came out about IBM developing a new quantum processor. And this new quantum processor has 127 qubits. I believe IBM's prior processor, quantum-wise, had 32 qubits. So this is a significant advance, right? Maybe 4 times what they were able to do before. That's probably about right. They 4x'd it. And while that sounds impressive, what I'm about to read you will tell you that there's a long way to go. So the IBM says by 2023, we hope to be producing quantum processors with 1,000 qubits, which might make them useful in a business context. So what does that say right there? In one sentence, they said that it'll take 2 more years to get the processing power of quantum computers to the point where they might be useful for businesses. The pitch right now by IBM and others is what they call the hybrid cloud, and that is a mix of traditional computers and quantum computers with the 32-bit qubits in IBM's case. So they'll submit like something to be processed on a hybrid cloud that'll partially process on the quantum computer and partially process on traditional computers. Now we know that quantum supremacy was reached in 2019 and that was documented. In this case, IBM announced the new processor, but they have not documented the performance yet. In fact, they go on to say that. They call this new processor Eagle. And they believe that it will perform calculations that cannot be done by traditional computers in a reasonable time frame. But no benchmark demonstration has been made yet that shows that this new processor can actually perform tasks beyond the grasp of conventional computers, saying only that the machine is powerful enough to do so. So quantum computing is the computing of the future, most likely, right? Now, there's no guarantee that quantum computing will ever be made to work. And we know from a short that I recently did that traditional computers, specifically ones with processors to process AI algorithms, new processors have just been invented that are way, way more powerful. So traditional computing continues to advance in parallel with quantum computing, which is good because, as I said a second ago, quantum computing is not guaranteed to ultimately work out. This is a whole new field, but usually when a technology is worked on for a long period of time, it does end up working in some fashion. A perfect example of this is neural nets, because the first neural nets, if you go back and watch my history videos, were invented. The first one was invented back at the very beginning of artificial intelligence, right after the Princeton conference, the Dartmouth conference, where the term AI was first coined. Dartmouth, not Princeton. This says, that took 30 years to get the neural net working. Now, one thing we know is that everything is faster whether it's computers or outside of computers. Things are now changing at an exponential rate because of a number of exponential technologies, which I've talked about. And if you want to see a non-computing exponential change, check out the video I just did on oil drilling, which doesn't have directly to do with AI, but it does have to do with a complete breakthrough that lowers cost to do certain drilling by orders of magnitude, meaning it makes it much, much, much cheaper and much easier, and in this case, much safer. So this is the way everything is going. That's why I say it's likely that quantum computing will be solved at some point at scale. And when it does, talk about AI being on steroids. AI is greatly facilitated by two things. Much more powerful processors like the ones we just talked about, both in traditional computing for now, but later quantum computing. And the other is more and more data. So the data problem is getting fixed, which I will talk about in not this week's videos, but next week's videos. The data problem is getting fixed rapidly. The processing problem, as I just said, is proceeding along parallel tracks between much more powerful traditional computing processors and theoretically much more powerful quantum computing processors. But once quantum computing is commercialized, it will take AI to a whole other level in speed, and the reason why is because it can process algorithms that take a very, very, very long time with traditional computing very quickly. So this is a potential breakthrough. It's certainly a step in the right direction. It 4x's the power of IBM's previous qubit processor. And they're saying, well, hopefully in 2 more years we'll be at 1,000 qubits, which is, again, a major step change from this one just announced. Other companies, of course, are working on quantum computing. IBM is just a huge public corporation with a massive PR apparatus, but there's other sole focus quantum computing companies working on it, and it's quite possible that one of them will have the breakthrough to commercialization. But the efforts are ongoing, the funding is flowing in, quantum computing continues to advance steadily, and one day it will do things that are unimaginable with traditional computers, most likely. Thanks so much for tuning in. Check out my book on Amazon, The Beginner's Guide to AI, that gives you a very short but complete history of AI and then how AI is impacting 10 different industries today. Also, click the link below, get your free AI resource, and if you do that, you will get an opportunity to participate in the beta group for my new course, where you get to participate for free, and I hold your hand and walk you through the course. But the course is called, at this point, the AI Safe Career Pivot. And this is built to help you change jobs to something different than what you're currently doing that will be relatively safe in the medium term against AI automation, which is coming very, very quickly, as a bunch of my recent videos have explained. So thanks so much for tuning in, and we'll see you next time.